All right, this is our pre-calculus trigonometric identities proofs lab, and I'm going to skip around and do some questions with you um, to help you, give you some hints on how to do stuff. So you'll see me skip around. I'll make sure that I put which ones I cover in the title. So we're going to start with number one. And what I told you before is I want you to start on the side that is the most complicated. And when I look at this one, I see the left looks much more complicated than the right. So that's what I'm going to work at. Now I see a squared here, so I'm looking for an identity for cotangent squared theta. And I see a cosecant theta plus 1, so I'm wondering if it has something to do with that. So I'm going to look in the front of the lab. And cotangent and cosecant squared are actually the same identity. And if I'm solving for cotangent squared here, I can see that cotangent squared of x, if I move this over here, is going to equal cosecant squared of x minus 1. So I can actually solve for cotangent squared as well. So I'm going to actually use that identity when I do this. So instead of x, I'm going to use theta. So I'm going to use cosecant squared theta minus 1 in the place of the cotangent squared all over cosecant theta plus 1. Then I got a plus 1 equals cosecant theta. So all I did was replace the cotangent squared with an identity. Now I look at it, and this is the next thing I look at it. We're looking at algebra, and I see that this is a perfect square and this is a perfect square. This is a difference of two perfect squares, so I'm actually going to factor that to cosecant theta plus 1, cosecant theta minus 1, all over cosecant theta plus 1. And I have the plus 1 equals cosecant theta. So far, so good. And then I say, oh, wait a minute, these two can cancel out or divide out to make a 1. So now I have cosecant of theta minus 1 plus 1 equals cosecant theta. And then I say, oh, the negative 1 and the plus 1 cancel out. So I end up with cosecant of theta equaling cosecant of theta. And when you're done, you write it like this. You write cosecant theta all the way down. When you do a check mark with a line saying that you prove that this equation is an identity. And like I told you before, I love, love, love doing this. Okay? The next one I'm going to do is number 3. And remember, you have to do this whole lab, but I'm trying to pick a few different ones. And again, I look at this one and I see that the left side is much more complicated than the right. So I'm just going to play with the left. I see this is sine theta and cosine theta. Those are my building blocks. Remember, I call them that. So I look at cosecant theta to see, can I write that a different way? And when I look at the front here, I see that cosecant theta is 1 over sine x in this place. So we're going to just put that in that spot. So I have, ready, sine of theta times 1 over sine of theta times cosine of theta equals cosine of theta. Now, if this helps you, you can put this over 1 if you will, but sine theta over 1 times 1 over sine theta, they cancel out and make a 1. I end up with cosine theta equals cosine theta. So this one's a quick one and I've got that identity to work. All right. The next one I'm going to do is number 6. Okay. So when I look at 6, the left looks much more complicated, so that's what I'm going to do. And I see that they have a cosine here and a cotangent and a secant, and there's a lot of ways you can do this. But and I'm showing you one way. There could be many ways. I'm going to put everything in building blocks. So when I say that, I'm going to look at sine and cosine. So the cosines here, secant, I know is 1 over cosine of theta. And then I'm going to times cosine of theta minus, and then cotangent, I can write as 1 over tangent, but I also can write it as cosine of theta over sine of theta. So that's one of the identities on the page, and I'll go back and show you that. That's right here in the middle. Cotangent is cosine over sine, tangent is sine over cosine, okay? So we're going back down, sorry to do that. And that's going to equal 1 minus cosecant theta. So I'm just going to keep writing the right until I get the left to match. Now I'm going to distribute and put that over 1, if you will. And when I do that, those cancel. So I end up getting a 1 minus. And then when I multiply 1 over cosine times cosine over sine, the cosines cancel, so I end up with 1 over sine of theta equals 1 minus cosecant theta. And then I know that 1 over sine is cosecant, so I have 1 minus cosecant theta equals 1 minus cosecant theta. And so I got them to match, and I proved that identity. Let's see what's the next one I'm going to do. I try to do different ones. Let's go to number 9. Okay, so when I do number 9, I see that the left side is more complicated, and I have a fraction thing going on. So I've got cosine squared over here, so I'm going to play with the left. So I'm going to use purple this time. So I got 1 minus. I'm going to actually leave the numerator alone because that's a building block. And down here, I'm going to write cosecant as 1 over sine theta, which we have done before, equals cosine squared theta. Now, when you look at this is a complex fraction. And there's 2 ways you can do this. You can say, all right, I have sine theta divided by 1 over sine theta, which is the same as saying sine theta times sine theta over 1. Or you can say, well, this is a complex fraction, so I have to multiply the numerator and denominator by the denominator, the common denominator of the both, which is sine theta. And when I do that, I end up getting 1 minus, this cancels out and makes a 1, sine squared theta equals cosine squared theta. Now again, if you don't want to use the complex fraction rule, then you can go ahead and write it as sine times sine theta over 1. It's the same thing. It works out. Now I look at 1 minus sine squared, and I bet you that's one of my identities, and yes it is, identities. So I look at it here, 1 minus sine squared is cosine squared. So we're going to do that. So they match. So I have cosine squared of theta equals cosine squared of theta, and I got my sides to match. Okay. Let me see what is another one I can do that will help out here. Let's do 16. So I'm just kind of skipping around. You have to do them all, but I'm trying to do the ones that might be tricky. So when I do 16, I look at the left, obviously, because it's much more complicated, and I'm going to do common denominator. So I see that my common denominator must have sine theta and cosine theta, and that's one of the factors. So that's going to be my common denominator. So I have sine theta, cosine theta, minus, because when I'm subtracting, I have to have common denominators. And when I do this, I have 1. And then I see I'm missing cosine. So my smart one that I'm going to multiply the top and bottom is going to be cosine theta over cosine theta. So I end up getting right here cosine squared theta. Once you have a common denominator, I always tell everybody now they're in love, you're going to combine your numerators. So you're going to end up with 1 minus cosine squared theta, okay, all over sine theta cosine theta, which equals tan theta, all right? Keep working on it. Now I know that 1 minus cosine squared is my identity of sine squared plus cosine squared, so I know 1 minus cosine squared is actually sine squared theta, all over sine theta cosine theta, which equals tan theta. And then I see, oh, yay, I have 2 sine. This is actually sine theta times sine theta, so I'm going to cancel out one of them. So I end up with a sine theta over cosine theta equals tan theta. And I'm a little bit running out of room because I write big here, so keep going down. So I say the left is going to be tan theta equals tan theta, because sine over cosine is tangent, and I got it to match. So I kind of got a little carried away with my heart, but that's how you do that. So I'm going to make another video with some other practice problems, but that's how you're going to do those. I hope they help.